to
its
bring
size,
such a huge
the fact that
object.
it's unusually large is what's making you doubt that or at least be open to the possibility that it's not just a comet?
That's one aspect. And the second is that the trajectory is aligned with the plane of the planets around the sun. Now, we will get a good image of it when it comes close to Mars on October 3rd. We don't need to wait a lot. And there is a camera called HiRISE on the Mars Reconnaissance Orbiter that can image it with a pixel resolution of 30 kilometers.
Scientists are alarmed. Harvard's Avi Loeb has revealed shocking new findings about the mysterious space object, 3I/ATLAS, moving through our solar system. NASA originally labelled it as a comet, but it's showing behaviour that seems impossible, which has Loeb very concerned. The object is glowing with energy equal to 10 nuclear plants and travelling along a strangely precise route past Earth. When NASA's Hubble Space Telescope captured the first detailed images of 3I/ATLAS, researchers quickly noticed something highly unusual that doesn't fit the behaviour of normal comets or asteroids. The way light spreads around the object breaks nearly every rule of space physics. Most comets have a glow that fades gradually outward from their centre, like slowly walking down a slope on the beach. The brightness weakens bit by bit in a smooth, predictable pattern that scientists can measure with ease. But 3I/ATLAS behaves in the exact opposite way. Its glow doesn't fade gently. It cuts off suddenly, like stepping straight off a cliff. One moment, there's bright illumination, and the next moment, it vanishes. This abrupt cutoff is the kind of effect you'd expect if the light were coming from inside the object itself, like a powerful flashlight or internal energy source, not just sunlight bouncing off its surface. It's almost as if something within 3I/ATLAS is producing its own light and shining it into the surrounding space. Even more puzzling, the Hubble images show that this glow is concentrated at the front of the object facing the sun, not trailing behind as a comet's tail normally would. Comets eject material away from the sun, yet this one doesn't follow that rule. Scientists tried to explain the glow as surface dust evaporating, but the numbers don't support that theory. The sharp on-off light patterns suggest something much stranger is at work, something outside the scope of normal physics. This was the first big warning sign that made Loeb consider whether this object could be something entirely new and possibly artificial. The most striking discovery about 3I/ATLAS is how much energy it appears to be producing. After studying data from several telescopes, Loeb calculated that the object is generating about 10 gigawatts of steady power, the equivalent of 10 full-size nuclear power plants. That's enough energy to run a major city. For comparison, the Hiroshima bomb released 15 kilotons of energy, and 3I/ATLAS is producing that much energy every few seconds, continuously. This is what raised the biggest alarms. Natural objects simply do not put out this kind of power. Even the brightest comets we've ever studied fall far short of this level. Comets shine because sunlight reflects off their surface and dust tails. They don't create light on their own. But 3I/ATLAS's energy output has remained constant. It isn't dimming or changing the way you'd expect if it were just ice melting or dust burning away. Something inside or around this object is pumping out huge amounts of power steadily. Loeb considered every natural explanation he could. Could it be a miniature black hole? The math says such an object would only produce about 20 nanowatts, millions of times too weak. Could it be radioactive leftovers from a supernova? There simply isn't enough stray radioactive matter in the universe to explain it. After eliminating every natural cause, Loeb was left with a controversial conclusion. The only explanation that fits the data is an artificial power source, something like a nuclear reactor. The energy profile matches what we would expect from a controlled nuclear system, not a random natural process. This steady, massive, continuous power output is the strongest clue that 3I/ATLAS may not be a natural object at all. Nothing we currently know about comets or asteroids accounts for a rock in space generating this level of energy on its own. One of the most confusing parts of the investigation is figuring out the size of 3I/ATLAS, and this is where things get even more intriguing. At first, NASA scientists assumed the object must be huge, around 20 kilometers wide, roughly the size of Manhattan, because of how bright it looked from Earth. That would place it among the largest comets ever seen. But this assumption created a major problem. Interstellar objects that massive should only appear once every 10,000 years or more. The chance of spotting one right now, just 8 years after Oumuamua, our first confirmed interstellar visitor, would be beyond unlikely, like winning the lottery twice in a row. That's when Loeb's team realized something groundbreaking. If the object is producing its own light instead of only reflecting sunlight, then it could be much smaller than it appears. Possibly only about 100 meters across, the size of a football field. This would completely change how we view it. If it's actually much smaller but still generating massive amounts of energy, its power output becomes even harder to explain naturally. The size factor is crucial because it hints at why such an object might have been sent into our solar system. A smaller craft would be far easier to accelerate to high speeds and control precisely. That's exactly how we would design a space probe, compact and efficient, not huge and unwieldy. If 3I/ATLAS is indeed football field-sized, it perfectly matches the kind of design you'd expect from an artificial probe, large enough to carry equipment, but small enough to maneuver with efficiency. This possibility is one of the most convincing signs that 3I/ATLAS may not be what NASA first thought. If it's not a giant comet reflecting sunlight, but instead a smaller, self-powered object, then everything we thought we knew about it has to be reconsidered. But perhaps the most unsettling revelation is the path 3I/ATLAS is taking through our solar system. Normally, comets and asteroids travel in unpredictable, chaotic orbits shaped by gravity and their initial push. 3I/ATLAS, however, is moving on what Loeb calls a suspiciously precise trajectory. His calculations show that its path brings it close to 4 different planets: Earth, Mars, Venus, and Jupiter. Not just one by coincidence, but 4 of the biggest planets in our solar system. The odds of a random interstellar object passing near all 4 is incredibly small, less than 0.005%. Loeb explains that in 99.995% of situations, an object like this would simply zip past without any significant interaction with planets. What makes this case stand out is how perfectly timed the trajectory appears to be. On December 19th, when 3I/ATLAS makes its closest pass by Earth, it will be positioned on the far side of the Sun, making it impossible for us to observe directly. This arrangement almost seems deliberately designed to let the object watch Earth while keeping itself hidden, as if someone wanted to study us without being noticed. Some astronomers dismiss this as pure coincidence, but Loeb argues the mathematical odds of such a trajectory occurring by chance are extremely small. It almost looks like the object is moving on a carefully planned route through the solar system, aimed at examining planets while avoiding close scrutiny from Earth. This isn't just out of the ordinary, it's statistically close to impossible without some type of guidance or intelligence involved. While mainstream researchers continue to focus on natural explanations, the raw numbers suggest something far more unusual may be happening. When 3I/ATLAS reaches its nearest point to Earth on December 19, 2025, it will be hidden directly behind the Sun from our perspective. That means even Earth's most advanced telescopes won't be able to track it during the most important moment of its journey. This unusual timing has left scientists puzzled. It's almost like someone trying to take your picture while standing behind a blinding spotlight right as the camera goes off. You wouldn't see them at all, while they'd capture you in perfect clarity. What makes Avi Loeb and others suspicious is how precisely this alignment matches the object's path. If 3I/ATLAS were moving randomly through space, the chance of it being blocked by the Sun exactly during its closest Earth pass would be incredibly unlikely. This alignment creates what you could call a one-way window. If 3I/ATLAS carried any instruments or cameras, it would have a perfect sunlit view of Earth, while Earth's telescopes would see only glare. Some researchers insist it's just chance, pointing out that objects often pass behind the Sun during their travels. But what stands out is not that the Sun blocks our view at some point. It's that the blocking occurs at the single most important moment. Because of this, space agencies have rushed to collect as much information as possible before and after the December alignment. NASA and other groups are working to coordinate observations from both ground observatories and space-based telescopes to maximize data during the visible phases of its journey. Some have even suggested using spacecraft around Mars or Venus to continue tracking it while Earth is blocked. But these instruments don't have the same resolution as Earth's most powerful telescopes. The Sun blocking event is only one of several oddities in 3I/ATLAS's path. Its course also takes it near Mars, Venus and Jupiter, almost like a deliberately mapped tour of the solar system's major planets. NASA is especially interested in what the Mars Reconnaissance Orbiter might capture when the object passes closest to Mars on October 2nd. That data could be vital before 3I/ATLAS disappears behind the Sun later in the year. Whether it's intentional or just a strange coincidence, the way 3I/ATLAS lines up with the Sun remains one of the most puzzling aspects of its passage. It continues to spark debate about whether the object is truly natural or whether its path was somehow planned. The arrival of 3I/ATLAS comes only 8 years after astronomers spotted Oumuamua in 2017, the first confirmed interstellar visitor ever detected. The short gap between these rare discoveries has raised many eyebrows in the scientific community. Detecting one interstellar object was already extraordinary. Detecting another less than a decade later was unexpected. Now, with a third showing such unusual traits, some believe it may no longer be coincidence. Scientists point out that interstellar objects should be extremely rare. Models suggest we might only detect one every few decades, or even once a century. Finding two strange ones within just 8 years challenges those predictions and makes people wonder if there is a connection. Both Oumuamua and 3I/ATLAS share features that set them apart from normal comets or asteroids. Oumuamua baffled scientists with its cigar-like or pancake-like shape and unexplained acceleration as it exited the solar system. It didn't produce a visible tail even though it passed close to the Sun. Similarly, 3I/ATLAS doesn't display the typical characteristics of a comet. Harvard's Avi Loeb has suggested the boldest idea, that both might actually be artificial in origin. If that were the case, then Oumuamua could have been an early scout, while 3I/ATLAS could be a larger, more advanced craft sent later. As Loeb notes, this is exactly how humans explore. We send small probes first to collect data, followed by larger missions with better instruments. If another civilization were exploring our solar system, they might use the same method. The size difference fits the theory. Oumuamua was relatively small, about 100 to 170 meters long, while 3I/ATLAS could be kilometers across. That kind of step-up mirrors how we design our own missions. Their orbits also show striking similarities. Both entered from unusual angles, outside the flat orbital plane of most planets. Both moved too fast to be trapped by the Sun's gravity. both also passed relatively close to Earth. And the timing is the most curious part of all. If they were natural, randomly ejected objects, the chance of two such unusual ones showing up only 8 years apart is almost zero. This has led some to wonder whether they could be connected, perhaps fragments from the same star system or even part of the same mission. Some astronomers argue they may have been expelled together by gravitational interactions near a star, which would explain their similar timing. While most researchers remain doubtful of the artificial theory, the link between these two mysterious visitors has become one of astronomy's biggest puzzles. And the journey of three I/ATLAS through our solar system may hold the key to understanding it. Even though Avi Loeb's theories about 3I/ATLAS possibly being artificial technology have created a lot of buzz, most of the astronomical community firmly disagrees with him. The majority of scientists believe there's a much simpler answer, that this object is nothing more than an unusual interstellar comet. In science, researchers often rely on Occam's razor, which says the simplest explanation is usually correct. And in this case, the most straightforward conclusion is that 3I/ATLAS is a normal comet that was thrown out from another star system, much like the countless comets ejected from our own solar system over its history, explains Samantha Lawler, an astronomer at the University of Regina. Many astronomers highlight new images that clearly show 3I/ATLAS with a faint but visible cometary tail, directly countering Loeb's earlier suggestion that it lacked such features. The tail isn't as dramatic as some comets, but it strongly points to a natural object releasing gas and dust as it moves closer to the Sun. The unusual brightness patterns that Loeb points to as signs of an artificial origin have far more ordinary explanations. Mainstream astronomers note that comets often display uneven brightness because of irregular outgassing from their surfaces. As pockets of ice heat unevenly, they create jets that trigger sudden brightness changes and strange light effects. Researchers who have studied many comets know they rarely behave in a neat, predictable way. Some comets have multiple jets, odd shapes, or unusual chemical mixes that produce strange optical effects when viewed from Earth. What may look mysterious to the public is usually just a normal variation to comet specialists. On Loeb's claims about nuclear-level power output, other scientists argue that his numbers rely on assumptions about reflectivity and composition that aren't backed by evidence. Instead of self-generated light, the brightness could easily be explained by a reflective surface such as fresh ice. Astronomers also stress that 3I/ATLAS isn't particularly large compared with other well-known comets. While estimates place it at a few kilometers across, that's still far smaller than famous comets like Hale-Bopp at 46 miles wide or Bernardinelli-Bernstein at 85 miles. Many scientists express frustration that dramatic claims about alien technology overshadow the real scientific importance of 3I/ATLAS. They argue that this kind of speculation distracts from what matters most, the opportunity to study our third confirmed interstellar object in detail. This is a once-in-a-lifetime chance to examine material from another star system, says one planetary scientist. We should be concentrating on what it reveals about the chemistry and conditions around other stars, instead of jumping to artificial origins without evidence. Despite the strong consensus against his idea, Loeb continues to promote his more unusual theories. This persistence has created tension among scientists, with many worried that speculative claims attract far more media attention than grounded, data-based explanations. As telescopes follow 3I/ATLAS through its journey across the solar system in the coming months, both sides of the debate are waiting for new data that could finally bring clarity. But as history with Oumuamua has shown, some mysteries about interstellar visitors may remain unanswered long after they pass by. One of the strangest findings about 3I/ATLAS comes from the FRX Observatory, which recently detected something very unusual in its chemical makeup. Their instruments revealed a large cloud of carbon dioxide, CO2, surrounding the object, but surprisingly, no sign of water vapor. This puzzled astronomers because typical comets almost always show both water and carbon dioxide as they heat up near the sun. Water is usually the most abundant and easiest to detect. The lack of water has left scientists scratching their heads. Some suggest that 3I/ATLAS may have formed in a part of space with a very different chemical environment compared to our solar system. Others think the water might be present, but somehow hidden from current instruments. Loeb, however, points to this chemical oddity as more evidence that 3I/ATLAS may not be a normal comet. The presence of CO2 without water doesn't match our models of comet formation and behaviour, he says. It's possible the CO2 is being released as the object heats up near the sun, but without water, which should be far more abundant and easier to spot. This explanation feels incomplete. Some scientists suggest the water could be trapped deep inside, not yet evaporating enough to be detected. As 3I/ATLAS approaches the sun, more water might appear. Another theory is that the comet already lost much of its water during its long journey through space, as cosmic radiation can gradually destroy water molecules over millions of years. But that still doesn't explain why so much CO2 remains. The chemical makeup of an object tells us its history and where it came from, one planetary scientist explains. Finding this much CO2 without water is like finding a fingerprint that doesn't match any known record. When astronomers get a closer look at 3I/ATLAS during its near passes by Mars and Earth, they'll be watching its chemical signature very carefully. If water vapour suddenly shows up, that would back the idea of it being a normal comet. But if the strange CO2 only pattern continues, it will deepen the mystery. This unusual finding is a reminder of how little we know about objects from outside our solar system. With only 3 confirmed interstellar visitors ever detected, every new observation pushes the boundaries of our understanding. The second visitor, 2I/Borisov, showed up in 2019. Unlike Oumuamua, Borisov looked and acted much more like an ordinary comet, complete with a visible tail and chemical signatures we recognise. This gave scientists more confidence that at least some interstellar objects would resemble what we usually see in our own solar system. Now 3I/ATLAS gives us a fascinating third example. It seems to sit somewhere between the total oddness of Oumuamua and the more familiar nature of Borisov. While it shares a few comet-like traits, it also displays strange features that don't fully match the usual pattern. With only 3 cases so far, it's extremely difficult to define what's typical for interstellar objects, explained one astronomer studying it. It's like trying to figure out all dogs by only ever seeing 3 of them. What makes these interstellar visitors so important is that they bring matter from other star systems directly into our solar system. It's like receiving free samples from places we could never reach ourselves. Each object acts as a time capsule, holding information about the chemical makeup, formation processes, and surrounding conditions of distant stars. They have been travelling for millions or even billions of years through the vast spaces between stars to finally arrive here. These visitors give us a direct window into other solar systems. As one scientist put it, they show us what's out there without us needing to travel light years to see it ourselves. The discovery of 3 interstellar objects in just 8 years has completely shifted astronomers' views. Before Oumuamua appeared in 2017, many scientists believed these objects would be extremely rare. Maybe one would pass through our solar system every few decades or even centuries. But finding 3 so close together in time suggests they are far more common than expected. There could be thousands, even millions, of such objects passing through our solar system at any moment. The difference now is that we finally have the technology to detect them. 3I/A TLAS stands out not just because it's rare, but because it was found early enough to study closely. Unlike Oumuamua, which was already leaving the solar system when it was first noticed, 3I/ATLAS was spotted while it was still on its way in. This gave scientists months to prepare observations and collect data. That kind of early detection provides a rare opportunity to study material from another star system in detail. Every bit of information we get from 3I/ATLAS helps us learn more about what exists in the spaces between stars, and may even give us clues about how our own solar system formed. Whether it turns out to be an unusual comet or something far stranger, its place as the third confirmed interstellar visitor makes it an astronomical prize that researchers will continue studying for decades. As 3I/ATLAS continues moving through our solar system, astronomers are getting ready for a series of close approaches that could give us the best chance yet to observe this object. These flybys have scientists around the world preparing their telescopes for what may be a once-in-a-lifetime opportunity. The first close approach will occur on October 2nd, 2025, when 3I/ATLAS comes within about 17.5 million miles of Mars. While that sounds like an enormous distance, in cosmic terms, it's very close. Scientists even describe it as practically within arm's reach on the cosmic scale. The final key moment will happen in 2026, when 3I/ATLAS swings past Jupiter at a distance of only 33 million miles. The strong gravity of the giant planet could slightly alter its trajectory, giving astronomers valuable insight into the object's mass and density. Scientists are especially enthusiastic about these flybys because each one allows them to view 3I/ATLAS from different perspectives and at different distances. Every pass might reveal new details about its structure, chemical composition, and behavior. Space agencies across the globe are coordinating their plans to make the most of these short viewing opportunities. Observing time is being scheduled months ahead, and specialized instruments are being prepared to capture as much data as possible during each flyby. Whether 3I/ATLAS proves to be just an unusual comet or something far more surprising, these close approaches are our best chance to uncover its true nature before it disappears from our solar system for good. Thanks for watching this video, and we will see you in the next one.